Tech in 5.
Dive into Python with a fun game. Learn in just 5 minutes.
Welcome back to our tic-tac-toe gaming adventure. In our previous video, we laid the foundation with basic tic-tac-toe gameplay. Today, we'll explore the state design pattern to enhance our game with different modes. Let's dive in. Imagine a martial artist's journey as a series of states in software design. This journey has distinct phases: practice, game, defeat, workout, and win. Each phase represents a state with specific behaviors and responses. State design pattern manages complex behaviors and transitions in software, ensuring each state operates within its defined scope and responds appropriately to changes, just as a martial artist adapts to each phase of their journey. Let's take a look at the implementation of our ongoing enhancement. In our main loop, instead of juggling various conditions and states, we simply call GameStateManager's update method. This one line delegates the responsibility of checking and changing states to our GameStateManager. The GameStateManager serves as the central hub for our game state management. It switches between different states like menu, game, and game over. First, we're focusing on the menu state, where the journey of each tic-tac-toe game begins. When the game state is set to menu, the GameStateManager calls the handle menu method. In handle menu, we use the getSelection method of the menu class to detect the player's choice. If the player is still making a decision, indicated by waiting, we redraw the menu to reflect any updates. Once a choice is made, the game mode and turn order are set, and we transition to the game state, ready to start the tic-tac-toe match. Now, let's take a closer look at the menu class, which is designed to handle the display and interaction of the game's menu. It presents the player with various options like easy mode, hard mode, and free play, each with configurations for who goes first, the player or the AI. In the draw method, we render each menu option on the screen, ensuring they are spaced appropriately for easy readability and interaction. We also store the rectangles for each option, which we'll use for detecting mouse clicks. The getSelection method is where we listen for mouse click events. When a click is detected, we check which menu option's rectangle contains the click. This determines the player's selection. The handle option selection method maps the selected option to the corresponding game mode, which is then returned to the GameStateManager to set up the game accordingly. This allows players to choose their preferred gameplay style and who starts the game. Once the menu selection is made, our game enters the game state. This is where the core gameplay unfolds. In the handle game method, the first step is to draw the game board. This is handled by our gameplay manager, which takes care of rendering the tic-tac-toe grid and any existing marks on it. Next, we process player interactions through the handle events method. This includes detecting where the player clicks on the board and making the corresponding move. After each move, we check if the game has reached a conclusion, either a win for one of the players or a draw. If the game is over, we transition to the game over state. In handle game over, we first ensure an instance of game over is created, passing the screen and the current game state. The game over class then takes over, drawing the game over screen and providing options for the player to either restart the game or quit. The player's choice is captured and used to update the game state accordingly. Restarting the game returns us to the menu, while quitting ends the game loop. The game over class is straightforward. It takes the game screen and the current game state as parameters. When the game concludes, this class showcases a game over message and offers options for what to do next. In the draw method, we render two key pieces of text on the screen: game over, to acknowledge the end of the game, and press R to restart or Q to quit, to guide the player's next action. The getInput method listens for the player's response. If the player presses R, we bring them back to the start for another round. If Q is pressed, it indicates the player's wish to quit the game. This wraps up our focus on the game states and transitions. In our next video, we'll delve into the gameplay manager, the heart of the game's mechanics. Stay tuned for more insights into bringing the tic-tac-toe game to life.
Stay tuned for more videos on Tech in 5.